Hello, ladies and gentlemen, Mr. Guy here. We're going to be talking about parent functions today. So just kind of want to let you know up front what I'm going to be expecting from you over the next 2 days and what information you need to take away from what we do today. So first off, we're going to be talking about parent functions, which are these generic versions of a bunch of different functions that we're really going to be diving into all year long. Okay, basically the whole year, we're going to kind of jump from function to function that we talk about today and look at the specifics. But these are the generic version of them that we're going to talk about. What you need to do today, and your main goal today, is that you need to memorize these functions. And then you're probably like, Mr. Guy, memorize stuff? Like, you're really going to make me memorize them? Yes. You have to be able to look at them, recognize them, know what they're called, and know what's called the domain and range of them, okay? The domain, as we've already talked about, is the x values of things that exist for the x, while the range are the y values, what can exist in the y, what can come out of your function, okay? And so I'm going to show you this chart, and that's kind of going to be what we talk about today. And then tomorrow, you're going to have a quiz where literally all you have to do is recreate this chart for me. Okay, so the only thing that you have to do is you have to go through, and it's just going to be a blank version of this, and you're going to go in and say, okay, this is a linear function, and here's all the different things about it. Here's a quadratic and all the things about it, so on and so forth, okay? Now, that does mean that the academic honesty thing does come into play here, because this is something that's not going to be open note. I am asking that you do this not open note, that you put everything away, and you only are writing down these specific things, okay? So you have to be able to be honest with yourself. You have to be able to turn it in and know, okay, maybe I didn't get this right, but I'm going to be honest and be forward with what I'm doing here, okay? Now, let's go ahead and let's take a look at these parent functions and kind of the different things about them and what they are. So the first one is the linear function. This is one that you all should be familiar with from last year. And the cool thing about the linear function, the parent function for it is f of x equals x. And remember that f of x is just telling us it's a function, same thing as y there. But a linear function has these three important points when you go to graph it, okay? And when you guys go to tomorrow, when you're kind of taking the quiz on your own, I'm going to only be asking for these sort of general shapes of what they look like, okay? So normally I'd be more concerned about the points and things, but we'll get more into those when we go in more in depth on each of these functions. So for tomorrow, for your quiz, you're going to have to give me the name up here. So this one is linear. You're going to have to give me this graph. So in this case, just draw me a graph of a line, right? And it goes through the point 0, 0. And then the parent function, which in this one is f of x equals x, okay? And again, you guys have all seen lines before. We're all used to linear equations. Again, the x could have coefficients with it. It could have something added on to it. This is the parent function. This is the most generic version of a line that we have, okay? The domain for a parent function is x is a member of the real numbers. Any real number works for a line. You can put it into the line and you're good to go. The range is y is a member of real numbers. When you put in a real number, you'll get a real number out. There is no y's that will not show up. So that is the linear function. That's one you're probably very familiar with. They're kind of our generic line. The next one is called a quadratic. You saw these a little bit last year, but we're really going to be diving into these first thing in Algebra 2. So a quadratic is, by this parent function, f of x equals x squared. And its graph makes this U shape, which, as we know, is called a parabola, okay? Now, the quadratic makes a parabola toward this U shape, and that U shape actually is going to tell us about what the domain and range are. The domain is any real number. I can put any number into a quadratic, into this x squared, and I'm good to go. However, the range of the parent function is from 0 being included with a bracket to infinity, meaning that 0 is included, so it's 0, and everything above 0, but no negative numbers can come out of our quadratic. Okay. Now, later on, we're going to be talking about things called transformations, where we'll move this quadratic around, and then we can have some negative numbers. But for the parent function, the generic version, there are no negative outputs. So our range is from 0 to infinity. All right, now I'm going to move my camera over here, and we're going to look at a cubic function. Now, a cubic function has sort of this curvy S shape. You kind of want to think of it as a quadratic that the 1/2 is kind of turned downwards, all right? So it's curving up, and then curving down on the other side, okay? The cubic function comes from f of x equals x cubed. And if you notice over here, all of these have a kind of bigger name called a polynomial, and we'll be really discussing that more later in the year. You don't really need to worry about that right now, okay? But a cubic function, f of x equals x cubed, and what's cool about it is that the domain and range is the same as the linear function, all real numbers. Everything can go into your cubic function, and you'll get all the numbers out, okay? And you can kind of see that from the graph, how we're kind of going down, so we get all the negative y values, and we're going up, so we're getting all these, and we have all the x values that we need. So that's a cubic function, okay? So linear, quadratic, and cubic, those are our first three parent functions, okay? The next three we're going to look at, there's a total of 9 we're going to be looking at today that you need to make sure you have memorized for tomorrow. The next one is called the rational function. Now, this one is kind of very interesting, right? So rational function comes from the equation f of x equals 1 divided by x. And if you know a little bit about 1 divided by x, you'll know that if x equals 0, we're going to have a problem, right? You cannot divide by 0. That's going to be an issue. So what happens there is that we end up with this sort of weird thing that I have shown with a dash line, but that's actually not part of our function. It's actually, if you looked at it on a graph, you wouldn't even see it there. What's happening is that our function is getting as close to 0 as it possibly can, but not actually reaching it. It's getting really, really close to it, but can't actually get there. And that's being shown by our domain. We're going from negative infinity to 0, but not including 0, and then from 0 to infinity. Okay, so we're getting as close to 0 as possibly can, and then we're going from 0 and on, but we're not actually touching 0. What this thing here is called it's called an asymptote, okay? An asymptote is where our function gets really, really close to it, but it doesn't actually reach it, okay? We have the same thing. This is a vertical asymptote. We also have a horizontal asymptote with these rational functions, and so our range is actually the same thing as domain. All the y values up to 0, and then all the y values from 0 all the way up, and keep going on and on and on, okay? That's our rational function, the parent function being 1 over x. And again, just remember for tomorrow, the expectation is that you're going to be able to tell me the name, draw me a quick sketch of the graph, name the parent function, what the actual equation is, and then the domain and the range. Okay, so again, that's going to be your goal for tomorrow. That's what you need to kind of memorize tonight, what your homework is tonight, okay? The next one is a radical function, okay? Radical function involves a square root. Who would have thought? So f of x equals the square root of x is our generic version, and this is what the graph looks like. Okay, it has a point at 0, 0, and then it comes out and kind of does a little curve out. It does not have anything that exists over here at all, and so our domain is from 0, which is included, out to infinity. No negative x values can go in because we can't have the square root of a negative number, so that's restricted in our function. Same thing for the range. The only things that will come out are positive numbers, 0 to infinity. So our domain and our range are from 0 to infinity. The next one is the absolute value function. This is represented with these lines around your x, meaning the absolute value means the distance from 0. Okay, that's what it's telling us. You can also think of it as making things positive. So you put a negative number in absolute value, you get a positive number out. The domain for this one's all real numbers. You can put any number you want to into an absolute value function. I can put in 2, I can put in 7, I can put in negative 7, I can put in 2 7s, 139, whatever you want to put in, you can put in there. What can't come out, though, are negative numbers because absolute value makes them positive. So the range is 0, which is included, to infinity. All right, the last three we're going to talk about here. The first one is the exponential function. These are the ones we're really going to dive into towards the end of the year, okay? The exponential function is represented by f of x equals a to the x. That's our generic version. Now, I also have written down here e to the x. You don't need to write that one down next year or tomorrow on your quiz, okay? But we're going to see e to the x a lot. And here's what's weird about this. So a is just standing in for a number, okay? Any number, it could, except for 1. It could be 2 or 3 or 4 or 7 or whatever, and they're all going to have a shape like this in your exponential function, okay? So a would normally be a number. You'll a lot of times see 2 to the x or 10 to the x or something like that. E is actually a number. It's an irrational number, and it's a really common exponential function that we're going to see later in the year, okay? But the a is just standing for any old number, and this is sort of the graph that's going to happen, okay? And if you notice, this graph is all real numbers in the domain. I can put any x value into this function and I'm good to go. Okay, I can put anything in. However, you also should notice that there's nothing here underneath in negative y values, nothing in the negative y values. So my range is only from 0 to infinity, with 0 not being included. That's why I have a parenthesis there instead of a bracket. So not included, 0 to infinity is what my range is for the exponential function. Logarithmic function is actually the inverse of the exponential function. They're opposites of each other. And that's the kind of trick that'll help you remember for tomorrow, because the domain of the exponential function is actually the range of the logarithmic function. Y is a member of the real numbers. And then the range of the exponential function is the domain of the logarithmic function. Okay, so they're kind of opposites of each other. Our parent function for this one is log of x. It's literally just the word log of x. Okay, and yes, this is a function. Okay, it's doing something. And we'll see that more when we do transformations later. Okay, and it kind of, again, looks like the opposite of the exponential function. I have written down here this ln of x. This is another very common at logarithm that we'll see. This is actually the log base e, which kind of goes along with this one over here. I know right now you're probably like, Mr. I don't know what you're talking about. That doesn't make sense. You don't need to worry about that for right now. Just make sure you remember that this function is called a log function, and this one's the exponential. The last one we have is a cool one. This is sort of a bonus one for us. We're not going to really dive into this during the year. However, I would like you to kind of look at it for tomorrow, because it's going to have some interesting applications with some of the things we talk about in this chapter, okay? And this is called the step function. Why is it called the step function? Because it looks like a bunch of steps, right? Now, if you guys kind of remember a little bit back from Algebra 1, the closed circle means that it is a point that is included. The open circle is a point that is excluded, meaning my function exists, it goes along, right here it jumps up here. And then it exists, it goes along, and then right here it jumps up here, so on and so forth, and it keeps going. This kind of looks like an absolute value when we write the function out, except it's got almost like little L's. It's got little bottoms on it as opposed to just straight lines, all right? The domain of this one is all real numbers. You can put any number you want into the step function, it's going to work. But what's really cool about it is what the range is, because the range of this one is actually just the integers, okay? And that's what the z means. It means the integers. Because the step function, what it's telling you is what's the lowest integer, like round down all these numbers to the next lowest integer before you go to the next one. So for everything from 0 to 1, like 0.5 or 0.6 or 0.7, whatever I put in there, I round down to 0. And then once I get to 1 and go over 1, I round down to 1, and those are the outputs for the step function, okay? So the range of this one is just the integers, which is a pretty cool range to have, pretty unique for what we're dealing with, all right? So these are the parent functions. This is what you need to have memorized for tomorrow. Please make sure that tonight you take some time and you write these down and you think about them and you think of ways to memorize what the domain and range are for each of them, okay? It is really important for what we're going to be doing later this week into next week that you know these functions like the back of your hand. So when you look at one of them, you go, oh yeah, that's a quadratic, I know that one. Oh yeah, that's a cubic, I know that one, so on and so forth, okay? And again, tomorrow, please make sure you're being academically honest and you're not just copying off my notes and turning it in, all right? I would like to see a lot of honesty from you guys and make sure that you're doing your best faith effort here, okay? Thank you very much for watching, and I hope you have fun studying the parent functions.